Everybody, how are you? I hope you all guys will find it. Today in this video, I'm going to be building a perceptron from the scratch without using any built-in libraries like the PyTorch, TensorFlow, etc. We are just going to be using the NumPy for the basic calculations, and we are just be using the concepts of classes and functions. If you don't know what it is, you can watch my video this. So, and we will be using that concepts, the class, objects, and functions, simple functions, and we will be using that to in order to build a perceptron, a very basic perceptron for the classification or the binary classification problem. And for if you understand that, and if you understand that perceptron, you would be able to understand large neural network models like the CNN, the RNN, GNN, etc. So it's just a basic concept in the deep neural network. So without wasting any time, let's just go. So first of all, we will just import our library. And after that, we will just create a class of a person called the perceptron. Class perceptron. Okay. So then we will have to just initialize the weights and the learning rate and the inputs for each and every object that is creating from this class. So for that purpose, we will just create a constructor for that in order to initialize everything for a new object that is creating from this class. Okay, and here in the parameters you will just pass the number of inputs, how much you want your number of inputs. Okay, and after that you will just specify the learning rate for that. So the learning rate. Okay, and we have done that. Now we will just assign it to a variable and store it in a variable. Okay, what I've just did over here, I've just created an array of random variables, and in the range of these number of inputs, on the basis of these number of inputs, whether my number of inputs is 20, 30, 40, 50, and the plus one is over here for the bias term. Okay, so in each array, in the array of these weights, we have a bias also. In your, you know, the basic structure of the perceptron, where we have the bases and the weights, and we just add a bias term to it. So okay, then we have to define the learning rate. Our constructor is successfully made. Okay, now we will have to just multiply the inputs with its weight and add the bias term for that. So for that purpose, I will just create another function called linear function. Okay, so I will say like def. So simple. Okay, we have just created a variable in which we have stored the inputs. Actually, the a, the, you can say, at the rate is used for the matrix multiplication. So inputs is just like a vector matrix, and the input, the weights are also a vector matrix. So, and what we have just did over here, we have just excluded the first element, which is also a bias. So in each in the array of weights, we have just excluded the first element, which is a bias. Okay, so the first element should be excluded because it will always be a bias, and after the bias we will have the weights or related to each input. So we are taking this input and multiplying it with its weight. Then at the end, we are taking the first element. I have just told you that that will be excluded from the this array, and we are just adding it as a bias term to that z. Okay, so this is a variable, and we have just calculated it. Okay, and now we want to add it to an activation function in order to predict zeros or one. Okay, so that is simple. You will just have to say like okay, so the basic structure has been bolted, and now we just want the model. Okay, we just want to build a model. So for that model, we just want to have a prediction function, the loss function, the train function, the fit function. So now we will be just building functions related to the model. Okay, so for first of all, we will just have to build a function called the prediction, okay, which can make a prediction. Okay, so what we have just did over here, we have just made a prediction function, and in that prediction function, which is taking the inputs as a parameter, and we are creating a vector array or variable, and it is storing the inputs just generated from this linear function, okay, which are the weighted sum of each and every input, and then we are making a try except block statement, which is just saying that you have to first of all you have to try this. If this is don't not satisfied, so you have to just do this except. Okay, so here we are just creating an empty list, and in that empty list we are just executing the for loop for z in z. Okay, and we are just saying that predict dot append self dot activation function. So we are just creating that we are just calling the activation function, and from that activation function the zeros or one is the result of that activation function. Okay, so that zeros and one is storing in this prediction function because we have predicted the values. Okay, so that is simple. And the except block is just saying that if there is one input, so you will just have to do it for only once. Okay, and if it is more than one, so the try block will be executed. Okay, and at the end we're just saying that return prediction. Okay, simple. Now we will just want to calculate the loss. Okay, how much loss has been, the loss is just used for the difference between the actual outputs or the actual data and the predicted outputs. So what's the real difference between both of them? That how much the predicted values are far away from the actual values. Okay, so it will just calculate that how much your model is accurate. So this is how we use the loss function. Okay, simple. So we have just created a loss function which is taking the prediction or the predictions which is just predicted from the prediction function, and we are also getting the targets, which is the actual values of the function, and we are just minimizing subtracting the targets from the predictions, and we are just returning the loss. Okay, so that will be a loss. So the last function is to train the model. In order, we have just created all each and everything. The time is to just train our model, our perceptron model. Okay, simple. We have just created the train function, and here you can see over here that we have just taken the train function is just taking the inputs and the targets, and which you can say like the x-axis and the y-axis. Okay, simple. Then we have the prediction variable, and that prediction variable is just saying that we have the self dot prediction inputs. We are just calling the prediction function for for predicting the future. Okay, and that numbers and that zeros and ones will be stored in this prediction function. Okay, then we have the error, which is just calculating the error, how much your model is accurate. So for that purpose, we'll just call the loss function, and and that loss function is just taking two parameters, the prediction and the targets. So on the basis of this error, we just want to update our weights and bias. Okay, so this is the most important thing in the machine learning, or you can say like the deep learning, that we just want the back propagation, and in that for that back propagation, we just want to update our values of the weight and the bias in order to get the accurate result and minimize the error and uh, provide and increase the accuracy of the model. So for that purpose, we will just update our weights of the model and the bias. So in the first line, we are just updating the weights. I am ignoring the first value, which is the bias. Okay, I have told you in the beginning, and I am just saying that self dot learning rate, I am multiplying it with the learning rate. Okay, that self weight, for example, if we have the first weight for the first input, and we are just taking that and multiplying it with the learning rate, and then we are just multiplying it with the error, and then on the basis of each input, because input is related to one of its weights, so and we are multiplying it with the input. So each and every weight will be updated for each and every inputs in the beginning. Then we have the self-lot weight zero. At the index of zero, we have the bias term. So the bias term is also updating, and we have just saying that self-lot learning rate is equal to multiplying it with error. Now the point is that we are not multiplying the input with the bias term. Why? Because the bias is only one for all of the neural network. Here the weights are associated with each and every input, so that's why we are multiplying it with the inputs. Oh, sorry, we have just missed our one function called the fit function. Sorry for that. Okay, so this is just a fit function, which is just taking from you the number of epochs, the x and the y. Okay, the x, which is used on the basis of which we just find the y values. Okay, these are the target variables, the y, and these are the input variables, x. So now we will just want our data set and certain libraries. So for that purpose, you will just select and we also need a visualization library in it, because in the end I will visualize the results of this model. Okay, so these are just the important libraries. Okay, model selection, in which we use the train test split, because we just want to split the data into training and the testing data. And then we have the standard scalar, because we just want to divide all of our values in order to make them in a specific or certain range without affecting our result. Okay, so this is a simple structure how you can create a data set from the sklearn data sets library randomly. Okay, then we will have to divide the our data set into training and testing data set. Okay, so for that pursue just select the it means that 20% of will be our test side and 80% will be our training data set. Okay, we will not use our test data set, we will just use it for the accuracy of our model, to check whether our model is accurate with our data or not. Now it's time to scale our data set. Okay, now it's time to make our model. So for making our model, we just have to call the class and create an object of that class, perceptron. Okay, so for that purpose, I will just say like the perceptron equals, I will just call our perceptron function and class, and here we have to provide the two parameters, because our constructor is taking two parameters. You can see that the number of inputs is taking and the learning rate it is taking. Okay, so the number of inputs is equal to x train, and excluding the one, we will just select dot shape. Okay, simple. And then we just have to provide the learning rate. So the learning rate will be, for example, I just want to select 0.1. Okay, sorry. Now we will have to just fit this data into our model. So for that purpose, you will just select perceptron dot fit. Okay, and for that purpose, you will just have to provide the x-axis, the y-axis, and the number of epochs. Okay, so I will just select x train. Okay, then the x test, the y test. Okay, and number of epochs. Okay, so number of epochs will be, for example, I just want to say like 100. Okay, simple. You can decrease it or increase it in order to get high accurate model. Okay. Okay, so after fitting it to the model, so our model is now trained. Now we just want to make prediction with that model. So you will just say like prediction is equal to perceptron dot prediction, and we just have to write the x test because we didn't use that. So you will just have to write the x test. Okay, and it will prediction. It will provide us the prediction. Oh, okay. So we will have to just define our accuracy for that. So accuracy will become like accuracy is equal to np dot mean, and in that mean you will just have to like a prediction not equal, okay, not equal to the x test, sorry, the y test. Okay, so what we are doing over here is that, for example, if our prediction value is not matching to the y test, so we are counting that numbers, that how many times it is not matching to our expected values. Okay, so the predicted values is not matching to the expected values, and we are just counting that, and that after that we are just taking the mean of that numbers. So that will be our accuracy. Simple. Okay, so I've just copy paste this code because this is simple. And I am printing, first of all, I'm printing the accuracy, and then I'm taking the scatter plot of the X test, okay, without all of the rows, and the first column, okay, will be, which will be the X test, okay, and the X test all of the rows, and the second column, okay, which is the predicted values. Okay, simple. And I am predicting it, so the x6, the x level will be feature 1 and y level will be the feature 2. So now just run it. So here we go, we have just created our simple perceptron from the very basic, okay, and you can see over here that the accuracy is about 0.975, which is about 97.5. I think it's a lot more than that. So actually this is a synthetic data, so the accuracy is very high. But if it is not a synthetic data, the accuracy might decrease. Okay, so it's not about the accuracy, it's about how well performing you were. So it's really not about the accuracy of the model, is it? It's all about if this model can solve your problem or not. So it's all about that. And you can see over here that it is dividing the features into two binary data sets on the basis of its loss and accuracy function. And you can see over here that the blues are the you can see like the purple color dots are like the feature number one, and the yellow dots are like the features of yellow features. Okay, so this is a simple perceptron, and it is classifying our data into two different categories very well. So I hope you enjoyed our video well, and you have just got something new in this video. Thank you and have a nice day.